Hello and welcome to InsideWi-Fi, Video 48. 802.11a or G Preamble. Wi-Fi operates over a shared medium, where multiple devices transmit at different times, so the receiver needs a way to distinguish valid signals from background noise. The preamble serves this purpose. It is a known signal sent at the start of every Wi-Fi frame that enables the receiver to detect the transmission, synchronize with it and correctly decode the incoming data. Since the legacy preamble is the foundation for almost every Wi-Fi generation, it follows a very strict timing and structure. There are three parts in legacy preamble separated by guard interval. The three parts are: legacy short training field L-STF, legacy long training field L-LTF, legacy signal field L-SIG, legacy short training field L-STF. The legacy short training field, L-STF, is the first part of the preamble used for signal detection, setting the automatic gain control, AGC, and performing coarse frequency synchronization. Signal detection. It consists of 10 short repeating symbols. This repetitive pattern is easy for the radio to hear even in a noisy room. Automatic gain control, AGC. This is essentially the receiver setting its volume. If the signal is too loud, it distorts. If it's too quiet, it's lost. The L-STF gives the receiver a few microseconds to adjust its internal amplifier to the perfect level. Coarse frequency synchronization. In a standard 20 MHz OFDM symbol, there are 64 FFT bins, out of which 52 subcarriers are used, 48 data and 4 pilot, ranging from -26 to +26 excluding DC. However, the L-STF only populates subcarriers that are multiples of 4. It uses 12 subcarriers at indices -24, -20, -16, -12, -8, -4, 4, 8, 12, 16, 20, 24. This leaves large gaps between active subcarriers. In the time domain, this sparsity creates a highly repetitive pattern. Specifically, the symbol repeats every 0.8 microseconds. In a 20 MHz channel, subcarriers are spaced 312.5 kHz apart. Because the L-STF only uses every fourth subcarrier, the distance between active signals is 4 × 312.5 kHz equals 1.25 MHz. The receiver can reliably distinguish the signal as long as the frequency drift is less than half of that distance plus or minus 625 kHz. This allows the Wi-Fi chip to perform coarse frequency estimation even before it knows exactly what the channel looks like. Legacy long training field L-LTF. Legacy long training field is the critical second phase of the Wi-Fi handshake. While the L-STF wakes up the receiver, the L-LTF provides the mathematical precision required to decode complex data. The L-LTF is much longer than the short symbols of the L-STF to allow for this high precision measurement. Fine frequency synchronization. After the L-STF handles coarse offsets up to plus or minus 625 kHz, the L-LTF narrows that error down significantly to correct residual frequency errors within plus or minus 156.25 kHz, which is exactly half of the subcarrier spacing. This ensures the receiver's internal clock is perfectly in phase with the transmitter, preventing the subcarriers from bleeding into one another. Inter-carrier interference. Channel estimation. Since radio waves bounce off walls and objects, they arrive at the receiver at different times and strengths. Multipath interference. This is perhaps the most important role of the L-LTF. The L-LTF transmits a known sequence using all 52 subcarriers from indices -26 to +26, excluding DC carriers. The receiver knows exactly what the L-LTF should look like. By comparing the received signal to the ideal signal, it calculates a channel state information, CSI, matrix. Double guard interval. It starts with a long GI to ensure that any echoes from the L-STF have completely died down before the fine-tuning begins. 2 long symbols. The L-LTF contains 2 identical OFDM symbols. The receiver averages these 2 symbols together to reduce noise and improve the accuracy of the channel estimation. Total duration, 1.6 plus 3.2 plus 3.2 equals 8 microseconds. Legacy signal field L-SIG. While L-STF and L-LTF handles the physics of the connection, the L-SIG handles the logic that allows different generations of Wi-Fi to coexist. The L-SIG is a single OFDM symbol, 4 microseconds, that contains a 24-bit field. It is always transmitted at the most robust data rate, 6 megabits per second using BPSK modulation, to ensure every device in the area, no matter how old or far away, can decode it. Rate, 4 bits. This tells the receiver which modulation and coding scheme MCS will be used for the following data field, example, QAM64, QPSK, etc. Length, 12 bits. This indicates the number of bytes in the upcoming data payload. Parity and tail, 8 bits. used for error detection and to reset the convolutional decoder. In a modern environment with Wi-Fi 4, 5, 6 and 7 devices, they all listen to the L-SIG. An old 802.11a device cannot understand the high-speed data of a Wi-Fi 7 packet. To the old device, the data looks like random noise. The Wi-Fi 7 device sends a legacy preamble first. Even though the old device can't read the actual message, it reads the L-SIG and calculates, okay, at 6 megabits per second, this packet will take 800 microseconds to finish. The old device sets its network allocation vector, NAV, and stays silent for that exact duration, preventing a collision, talking over the high-speed data. In newer standards, HT, VHT, HE, EHT, the L-SIG acts as the boundary. Immediately after the L-SIG, the packet shifts gears into the modern preamble fields, like RL-SIG or HE-SIG-A. In our next video, let's see the anatomy of a legacy OFDM PPDU. Thank you for watching.